Hello everyone, welcome back to Calculus. This time we will continue working on antiderivatives. It's on the textbook section 4.10. And again, put it in a simple way, each derivative formula, there is an antiderivative formula. Okay, so I do have those formula listed, and make sure you do recognize the types of functions correctly. A power function and exponential function, choose those things. And also, we did a few examples, x squared, x cubed. I suppose these are easy enough, right? And also, we did some function like 1 over x squared. 1 over x squared precisely should not be considered as a power function. But anyway, if you consider 1 over x squared as x to the negative 2, this is a power function. So to this point, you can apply the anti-differentiation power rule to find out the antiderivative. Similarly, we consider 1 over x cubed in the same fashion. And also we mentioned how we handle square root of x and then 1 over square root of x. And also, don't forget this special case. 1 over x, it doesn't match a different formula. It is not part of the anti-differentiation power rule. Okay, because the derivative says the derivative logarithm, it is 1 over x. Then antiderivative 1 over x, it is ln log n of absolute value of x and plus an arbitrary constant in the end. And those basic antiderivative formulas will handle those simple types of functions. So simply with those antiderivative formulas, we may not do a lot of things. We cannot handle a lot of antiderivatives. We do need to have some additional rules. And the two additional rules I want to mention here, it is the sum and the difference rule. In words, for this part, we can say the antiderivative sum of two functions is the sum of antiderivatives. Antiderivative of difference of two functions, it is difference of two antiderivatives. The other rule, it is the constant multiple rule. Antiderivative of constant times the function is constant times the antiderivative. Okay. And then, well, don't overlook those two small things. With the help of those two rules, we can handle many different antiderivatives. So I'm not going too far. I'm still using the examples on the textbook. Example 4.52, part A, B, C. Actually, there's part D. So let's take a look if we can handle them easily. So part A, actually, another small thing was to mention. In the beginning, I said antiderivatives are integrals, but more accurately, we consider antiderivatives as indefinite integrals. Indefinite integrals. The integral in next chapter, they are mostly considered as definite integrals. Okay, so for now, as I'm saying, we are on the third big topic of calculus, integrals. But anyway, for the moment, it is about the indefinite integrals. This is the example 4.52, part A. Find out indefinite integrals. Find out the antiderivative. This is the antiderivative notation, right? Don't forget dx in the end. So because of the sum and the difference rule and the constant multiple rule, basically it allows us to handle the antiderivative like this, each term one by one. So this is what I did. Because of the constant, well, first of all, because of sum and the difference rule, I can handle the antiderivative each term one by one. And because of the constant multiple rule, I can take out this one. They handle the antiderivative of x to the power 3. Take out the 7, the antiderivative of x squared. Take out the 3, the antiderivative of x. And take out the 4, then I want to say this is antiderivative of 1, right? So which is x. And then for each using the anti-differentiation power rule, I got the antiderivative. Hopefully you help me double check if I got all the numbers correctly. If something not right, or if you have any questions, just let me know. Thank you. And let me see, I think probably I missed something here, right? 3 over 2x squared. I think I missed the term 4x. Okay. 4x. Now this should be the correct antiderivative. Then part B, well, I said several times, when you apply the anti-differentiation power rule, make sure you do apply to each individual power functions. But you cannot apply the power rule to somewhere in the numerator and to the numerator and the denominator separately. So for part B, this is what I did. First of all, I really did not use the antiderivative rules. I'm doing the algebraic manipulation because I understand this function here, the function in between the integral sign and the dx notation, it is called as the integrand. I know the integrand can be separated into two. Each term of the numerator divided by the same denominator. Also, for the third root of x, I understand that is x to the 1/3. Okay, and then it is clear x squared over x, that's a single x. Then 4 times x to the 1/3 over x, using the laws of exponents. I think that this should be turned into 1/3 minus 1. I'm sorry for the mistake. This really should be negative 2/3. This is 1/3 minus 1. So the result should be negative 2/3. X to the negative 2/3. Okay. Then antiderivative of x, that's from the anti-differentiation power rule. And then from the same rule, and also there's a constant 4, but we do know the constant multiple rule. So the 4 stays. Then this is for x to the power negative 2/3. So I should write down. This is to the power of negative 2/3. Negative 2/3 increased by 1. And this denominator should be the reciprocal of negative 2/3 plus 1. And then I believe the first term should be fine, 1/2 x squared. And the second term, negative 2/3 increased by 1. Should be just positive 1/3, right? And then there's 4 in the front. The reciprocal of 3, reciprocal of 1/3, that's 3. 4 times 3. So I believe this should be 12. This should be 12. This should be 12 here. This should be 12. Now I believe it should be correct. As I'm saying, if you see anything not right or you have questions, just let me know. Another example, antiderivative 4 over 1 plus x squared. Clearly, this is not going to, this function, this integrand, it does not match anything as a single power function. You cannot jump to x squared. And also, I guess there's not an easy way to separate 1 plus x squared into some single power functions because it's in the denominator. Okay, but I just realized actually besides the power rule, anti-differentiation power rule, we do have a formula to deal with 1 over 1 plus x squared. Remember the formula over here? Okay, the antiderivative 1 over 1 plus x squared simply is tangent inverse or arctangent. So really, for part C, the answer turns out to be very simple if you know the formula very well. It is 4 times arctangent or 4 times tangent inverse of x plus an arbitrary constant. Usually we put the arbitrary constant in the uppercase fashion. Okay. One more, let's try to see if I can explain part D. Part D. Part D seemingly may look very complicated. It is complicated, okay. How do we handle the situation of antiderivative tangent times cosine? We really don't have any easy simple formula to match the thing entirely. But I do know when we have trouble to deal with trigonometric functions, and we use trigonometric function identities. So specifically in this case, I know tangent x, okay, it is the quotient of sine over cosine, sine over cosine. So in my first step, I simply replaced tangent with sine over cosine. And then I realized actually the denominator cosine would cancel the other cosine. If you have any confusion if the other cosine is on the top or not, you could put 1 as the denominator for the other cosine. So you can see other cosine clearly it is on the top. The cosine and the cosine, they are canceled. Really, the antiderivative we are looking for after the cancellation, it is the antiderivative sign. And then according to the formula, antiderivative sign, it is negative cosine x. The formulas, it is one of the basic formulas I listed here. Antiderivative sign is negative cosine. Antiderivative cosine is sine. If you wonder how do we remember this minus sign, I say it's from the derivative rule. Because derivative cosine, that's negative sign. So accordingly, the antiderivative sign, that's negative cosine. That's all I can explain. And think it carefully to see if it makes sense. It should. Okay. So really, I say this is the discussion of section 4.8, antiderivatives. Antiderivatives are integrals, and indeed antiderivatives are indefinite integrals. Our last topic, it is about integrals, and certainly integrals, there are indefinite integrals and there are definite integrals. So next time we will work on definite integrals. Thank you for watching.